This lesson is how to find an empirical formula. That's important because that's what you find when you do an experiment, is the empirical formula of a compound, which is the smallest whole number ratio of atoms. The first step is find mass. If you're given a percent, you can just replace the percent sign with grams by assuming you have 100 grams of compound, because that won't change the ratio. Second step is moles. Third step is to find the smallest whole number ratio of the moles, which is giving you the subscripts in the empirical formula. The way you do that is by seeing if you have a whole number or a fraction, and then if you have a fraction like a fourth, a third, a half, or 2/3, you multiply by the denominator of that to get whole numbers. So for example, a sample contains 1.04 grams of potassium, 0.70 grams of chromium, and 0.86 grams of oxygen. Find the empirical formula. First step is mass. So we're just going to write down the masses given to you in the problem. And then the next step is moles. So you divide by the number of moles from the periodic table. When you plug that into your calculator, you'll usually get a number with a bunch of decimals. Go ahead and write out quite a few of them so it doesn't cause rounding errors and cause you to get a different formula than you want. So then you look at these numbers and you're like, I don't know what the ratio is in them. I'm supposed to be finding whole numbers. So the way you do that is divide all of them by the smallest number, which in this case is the 0.013 number. So that'll make at least one of them equal to 1. When we divide the other ones, we get 1.975 for the first one, 3.99 for the next one. At this point you ask yourself, are these numbers a fraction or a whole number? It's one or the other. And the only fractions you have to choose from are those ones in red, 0.25, which is a fourth, 0.33, a third, 0.5, a half, or 0.6, a 2/3. So I'm going to say, well, 3.99 is definitely closer to 4 than to a fourth, and 1.97, same deal, so it's a 2:1:4 ratio. And then you write your chemical formula. Write it in the same order that the problem gives you, so K and then CR and then O. There's 2 Ks because I found 2 at the end of my K calculation, and 1 CR and 4 Os. So this chemical formula is potassium chromate. Here's another example. Our first step is mass. So you write down the mass from the problem. It's given to us as percent, but I'm just going to call it grams. I found the 10.08% in grams by subtracting from 100. Then I convert from moles from the numbers on the periodic table. Now I'm going to divide both of them by the smallest number of moles to get a small whole number. So this one is 1, and this one turns out to be 1.33. I think to myself, oh, that's a third. So I multiply both of them by 3, both of them because I don't want to change the ratio, so I get 3 for carbon and 4 for hydrogen. So the empirical formula is C3H4. Here's one more example that you can try if you need the practice. The answer to this one turns out to be Al2O3.